Hello students, welcome to a course on engineering graphics. The topic of discussion is projection of solids. In this session, we are going to have a brief overview of solids. Also, we are going to understand how to interpret the problem statement as per general problem solution layout for projection of solids. Further, we will discuss the simple methods of drawing front view and top view in second and third position. Solid is defined as a 3D object having length, breadth and thickness and bounded by surfaces which may be either plane or curved or combination of both. In solids, specifically we are going to discuss prisms, pyramids and revolved solids. Prism is defined as a polyhedron formed by two equal parallel regular polygon end faces connected by side faces which are either rectangles or parallelograms. Pyramids are defined as a polyhedron formed by a plane surface as its base and a number of triangles as its side faces, all meeting at a point called vertex or apex. These are examples of prism. Based on the shape of their top and bottom bases, they are named as square prism, hexagonal prism, pentagonal prism, triangular prism. These are few pyramids, and based on the shape of their base, they are named as square based pyramid, pentagonal based pyramid, hexagonal based pyramid, and triangular based pyramid. Revolved solids are generated by revolving about an axis. Example, cylinder, cone. This figure is a representation of projection of top view and front view of a pentagonal prism. The corners of top face pentagon are marked with A1, B1, C1, D1, E1, and bottom face pentagon are marked with A2, B2, C2, D2 and E2. In the direction of top view, the top face pentagon is visible, bottom face pentagon is hidden, which is as shown here. So this corner A1 is visible, A2 is hidden, B1 is visible, B2 is hidden, C1 is visible, C2 is hidden, D1 is visible, D2 is hidden, E1 is visible, E2 is hidden. In the direction of front view, these front faces are visible, marked in blue. The corners enclosing these faces, A1 dash is visible, B1 dash is hidden, A2 dash is visible, B2 dash is hidden, E1 dash is visible, C1 dash is hidden, E2 dash is visible, C2 dash is hidden, D1 dash is visible, D2 dash is hidden. The problem statement can be sorted out in 3 steps. All the problems what we are going to discuss are with solid resting on HP for the first position. So in first position, first we will check the type of prism or pyramid. That is whether it is a triangular prism or triangular based pyramid, a square based prism or square based pyramid, etc. Second, we check whether corner is resting on HP or side is resting on HP. For second position, since the solid is resting on HP, the first inclination is taken with HP. Usually, the solid axis or longitudinal face is given the inclination with HP. In third position, where we consider the second inclination, we also decide whether a locus method is to be used or a no locus method is to be used. If axis is inclined to VP, locus method. If axis appears to be inclined to VP, then it is a no-locus method. If side or edge on which the solid rests is inclined to VP, then it is not a locus method. Now let us try to analyze a problem statement in 3 steps as discussed. Also, we will discuss how to draw the top view and front views in second and third position. A square prism 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base, such that the two base edges containing the corner on which it rests make equal inclinations with HP. From this statement, it is clear that for first position, it is a square based prism and it is resting with one of its corners on HP. We will draw the top view and front view. This is the direction of projecting the front view. In this direction, these edges are visible, marked in blue. These edges are marked with A1, A2, written here as A1 dash, A2 dash. This is D1, D2, written here as D1 dash, D2 dash. B1, B2 is hidden behind D1, D2. So they are in bracket as B1 dash and B2 dash. O1 dash and O2 dash are the axes. C1, C2 are visible. They are marked as C1 dash, C2 dash. Next, for second position, draw the projections of the prism when the axis of the prism is inclined to HP at 40 degree. Since the solid was placed on HP, the first inclination will be with HP. So we will incline the front view obtained here at 40 degree with HP. From this front view, we will project vertically down from all the corners. And from the top view obtained in the first position, we will draw horizontal projections. The corners of the top and bottom base are marked as follows. Here, projection from A1, horizontal projection, and A1 dash, vertical projection. They intersect at this point. This point is marked as A1. Similarly, projection, horizontal projection from A2 and vertical projection from A2 dash intersect at this point. This point is marked as A2. We will proceed and mark all the points in similar way. Now, the outermost points which mark the boundary of this solid are drawn using continuous thick line, which is shown in red color here. This is the first step. Second, this is the direction of viewing the top view for this position. The face of the square pyramid enclosed with A1 dash, B1 dash, C1 dash, D1 dash is near to the observer. So this face is visible to the observer. It is drawn in continuous solid line. The other face marked with A2 dash, B2 dash, C2 dash and D2 dash is away from the observer. So the remaining edges of this face are marked with dashed thick line, representing that these two edges are hidden. Then the longitudinal edges A1 dash, A2 dash, they are near to the observer, so they are drawn with continuous thick line. The other edges like B1, B2, D1, D2 are drawn in continuous thick line and they are forming part of the boundary. The other edge C1 dash, C2 dash is away from the observer. So C1, C2 is drawn with dashed thick line. Next, for third position, axis of the prism appears to be inclined to VP at 45 degree. Since the words appears to be inclined are there, it is not a locus method. We will draw a 45 degree line, and this top view of the solid is rotated to 45 degree line. Now we are viewing in this direction to draw the front view. We will draw the vertical projections from this top view and horizontal projections from the front view and mark the points as discussed. All outer boundary points are marked with continuous thick line. Next step, since this is the direction to view the front view for this position, the face enclosed with A2, B2, C2, D2 is visible. So this A2 dash, B2 dash, C2 dash, D2 dash is drawn with continuous thick line. The face marked with A1, B1, C1, D1 is away from the observer. So the remaining edges of this face are marked with dashed thick line. The longitudinal edges A1, A2 and C1, C2, they are part of the boundary lines. So they are marked in continuous thick line. The edges D1, D2 are near to the observer, so it is drawn using continuous thick line. The edge B1, B2 is away from the observer, it is drawn with dashed thick line. This is the summary of method to draw top and front view in second and third positions.